All right, this video we are going to be graphing linear functions, and we're going to be using some key features, including the y-intercept and the slope. All right, let's take a look at one here. We're just going to graph the following linear function on this coordinate plane. So the function we're going to use is y equals 2/3 x plus 3. All right, so I've told you, or you've seen, that we can create a table, all right, of ordered pairs. All right, remembering that this is our x and this is our y. And what I want to do is I want to start with 0. 0 means that we plug the 0 for x in to the function, and we multiply 2/3 times 0, and then we add 3. So again, just as a reminder, and you've seen this, but we do 2/3 times our 0, and then we add 3 at the end. Well, maybe you understand, but the 0 is easy to work with because anything times 0 is 0, and then plus 3 is 3. So we just get an output of 3, okay? Well, we can go ahead and plot this point 0, 3 over here on the graph. Start at the origin, and of course 0 on the x value tells us we don't go right or left, and then the 3 for the y value tells us we go up 3, 1, 2, 3, and we put our point right there, okay? So I'm going to go ahead and locate a point there at 0, 3. That's a point, okay? Now for my next input value, I'm going to use a 3, okay? That simply means I'm going to take 2/3, multiply times 3, and then add 3. Okay, so we put the we replace the x in the parentheses with the value with the input value. Now when we do that, 2/3 times 3 is actually 2, and then 2 plus 3 is 5. So we get an output of 5. That means our next point is at 3, 5. So we come over here, all right, and we go over 1, 2, 3, and we go up 1, 2, 3, 4, 5, and we put another point there. All right, so let me go ahead and put that point there. Okay, and then let's go ahead and do another one. I'm gonna go ahead and do 6. So I'm gonna put in I'm gonna plug in a value of 6. So again, one more time, let me show you. 2/3 times the input value plus 3. This is the function that we're using. So I'm gonna plug in a 6 here. And when we do that, okay, 2/3 times 6, that's 6 times 2 is 12, 3 times 1 is 3, and 12 divided by 3 is 4. So 4 plus 3 is 7. So our output is a 7. So now we have a 6, 7 that we need to plot. We go over 1, 2, 3, 4, 5, 6, and up 1, 2, 3, 4, 5, 6, 7, and we put the next point there. So here it is right here. Now, we can go ahead and graph that with a solid line going all the way through. So that would look something like this. All right. Now, what I want to show you is that you can always use the table, okay, to graph something like that. But notice when we start with 0 on this specific example, we get an output of 3. Well, that 3 is right here. So whatever you put into this function, when it's in what's called y equals mx, or slope, and then y-intercept form, y equals mx plus b, which I'm about to show you. Anytime you plug in a 0, this number over here is what's called the y-intercept. It's where it intersects the y-axis, because 0 and then whatever that number is, okay? Well, then you'll also notice that we have a rise and a run, okay? We have a rise of 2 units and a run of 3 units, okay? Every time we have a rise of 2, sorry, I'm having a little trouble drawing that on this video, and a run of 3. Okay? Every time we have that, I could do -2, I could do down 2, and to the left 3, -2/3. Well, again, just as a reminder, that 2/3 is coming from right here. So in a sense, what we've done is we've started at 3 over here, and then we've applied the slope of up 2/3. So we started at the y-intercept, and we go up 2/3, up 2/3, up 2/3 every time, or -2, -3, which is the same as positive. This is in what's called slope-intercept form, okay? Let me show you what that looks like. Okay, so this is the slope-intercept form. It's called y equals mx plus b. Again, it's called slope-intercept form. That's because we have the slope and we have what's called the y-intercept. That's the plus b. Here it is with actual numbers. So you have an equation or a function that says y equals 3x plus 2. The coefficient in front of x is 3. That's our slope, 3. Remember, that's a whole number of 3. However, we could call it 3/1 as a fraction. So we have a rise of 3 and a run of 1. And then this number out here, remember, if we plug in a 0 for x, 3 times 0 is 0, and plus 2 is 2. So this is where it's going to intersect the y. It's where it's going to intercept the y-axis, okay? So let's take a look at another one. I'll give you the function. Let's say it is y equals well, let's just use that one. So 3x plus 2. All right. Remember, the 3 is the slope and the plus 2 is the y-intercept. Okay. By the y-intercept, that means when I plug in a 0 for x and I multiply times 3 and I add 2, it's going to equal 2. Okay. It's going to equal 2. So whatever this number is the y-intercept. You come over here and you just go up 2 units on the y-axis and you put a point right there. So there is our y-intercept right there. Okay. And then we have our slope of 3. All right. Well, if m equals 3, it's also 3/1. That's our rise and our run. Okay, so from this point, we would go up 3 units and over 1, and we already have our next point. We just put our next point right there. Up 3 units, over 1. Again, go from this one, go up 1, 2, 3 units, because that's the slope. Or that's the rise, and over 1, that's the run. So we put another point right there. So once we put our point there, you can see that we have our straight line, because this is a linear function. And that is our line going through those points. I didn't draw that line exactly correct, but remember, this is continuous data, so we would have an arrow, okay? Again, how did we do that? We used the slope-intercept form. The intercept was plus 2, 0, 1, 2, so we have a 2 right there. I need to move my line over a little bit, and then we go up 3/1, up 3/1. Okay, let's try one more. Let's say we have our function is y equals -3/4 x minus 3. Again, this is in what's called slope-intercept form. Y equals mx plus b. The slope is a number in front of the x. That's the rise and the run. Notice this is negative. That means it's going to be going downhill from left to right, okay? And this is called our y-intercept, because when we plug a 0 in for x Anything times 0 is 0, and then of course 0 minus 3 is 0. So we end up with an ordered pair. When you plug in 0, you get -3. That's called the y-intercept because it's a point on the y-axis, and it's where this graph is going to cross or intercept the y-axis, and it's at 0, -3. Well, -3 means we go down 1, 2, 3 units, and we put a point right there. So now we have that point. Then we don't have to have a table to make this graph. We can just look at our slope. The slope is -3/4. Again, let me just write that out. It says slope, or m equals -3/4. And again, slope is the rise, or the change in the y, over the change in the x. We know it as rise over run. So we're going to rise -3, which means we're going to go from this point down 1, 2, 3 units. And then we're going to run +4. So we go down 1, 2, 3, and over 1, 2, 3, 4, and we put a point right there. And that's our next point. So I'll come over here and go down 1, 2, 3, and put a point right there. And that's really all you need is 2 points to create a line. However, just to make sure you understand, a -3/4 could also be written as 3 over -4, okay? So if it's 3 over -4, then we could go back to this point and we could go up 1, 2, 3, but then we would go -4, which is to the left, 1, 2, 3, 4. And then we would have a point right there. So let's go ahead and put that point on there. All right, and you'll notice that point actually is on the x-axis. So that's actually called the x-intercept, okay? It's also known as a 0, all right? So anytime it crosses the y-axis, it's called a y-intercept. When it crosses the x-axis, it's called the x-intercept. But then we can go ahead and sketch the line that goes through those. I'll go ahead and do that here. It may not be perfect, but let's see. It's basically going through that point, those points right there. So let me try that one more time. It's going to go through those. And remember, we could go ahead and write our arrows on the end because it goes on forever. Okay, that is how you use what's called y equals mx plus b, or it's called slope-intercept form to graph an equation or to graph a linear function.